Hello everyone, and welcome! Today, we're going to take a look at a mathematical tool that on the surface might seem a bit abstract, but I promise you, it's actually one of the most powerful concepts in a business leader's entire arsenal, the quadratic function. We're going to break down, step by step, how this simple curve helps managers find that perfect sweet spot, that ideal balance between what you make and what you charge, all to hit that one magic number, maximum profit. Okay, so here's our roadmap for today. First, we're going to define the core problem that literally every business has to solve. Then, we'll build a mathematical model to represent that problem. From there, we'll use a surprisingly simple formula to find the exact solution. After that, we'll translate that solution into a real-world business decision, and to wrap things up, we'll go over some of the most common mistakes to watch out for.
All right, let's dive in. And notice, we are not starting with a bunch of formulas. We're starting with a high-stakes decision, a dilemma that every single manager faces. This isn't just about math, it's about the fundamental tension at the very heart of running a business that makes and sells, well, anything.
Think about it. This isn't a trick question. This is the puzzle we're here to solve. If you make too few of your product, sure, your costs are low, but you're leaving money on the table. You're not making enough to cover fixed costs like rent, and you're missing out on sales. But if you make too much, your material and labor costs just keep climbing, and you might even have to slash prices just to get rid of the extra inventory. That perfect answer, that sweet spot, has to be somewhere in the middle.
So to find that sweet spot, we can't just rely on gut feelings or guesswork. We need a system. We need to translate our business operations into the clear, precise language of mathematics. So let's build a model for a hypothetical company and see exactly how this process works. First things first, we have to track the money coming in. We call this our revenue function, or R of X. In this function, X is just the number of items we sell, and R of X represents the total cash we bring in from selling all of them. It's basically the top line of your income statement. Now for our model, we're going to use this function right here. R of X equals negative 2x squared plus 800x. Now you might be looking at that and thinking, why isn't it just price times quantity? Well, that negative x squared term is absolutely crucial because it makes our model much more realistic. It reflects a fundamental economic idea, the law of demand. To sell more of something, you eventually have to lower the price. So your revenue climbs for a bit, but then it hits a ceiling and actually starts to go back down if you cut the price too much. That's what this quadratic function captures so perfectly. Okay, so that's the money coming in. Next, of course, we have to model the money going out. This is our cost function, or C of X. This function represents every single dollar we have to spend to produce those X units. And it's made up of two different kinds of costs, ones that change and ones that don't.
For our hypothetical business, we'll use this function, C of X equals 100x plus 5,000. So let's break that down. The 100x part is what we call our variable cost. For every single unit we decide to make, it costs us an extra $100 in materials, maybe some direct labor, shipping, and so on. The 5,000, well, that's our fixed cost. This is the factory rent, the manager's salaries, the insurance. It's all the bills you have to pay every month, even if you produce absolutely nothing. This kind of straight line function is a really common and very effective way to model costs.
And now we get to the part that really matters, profit. You know, there's an old saying in business, revenue is vanity, profit is sanity. Profit is what's left over after every single bill has been paid. It's the bottom line. And this is the number we want to make as big as humanly possible. Our entire job as managers is to find the absolute peak of this profit function.
So, to build our profit function, we just subtract the entire cost function from our revenue function. Now look closely at this calculation. We take our revenue, that negative 2x squared plus 800x, and we subtract the entire cost function, 100x plus 5,000. A key mistake here is forgetting to distribute that negative sign to both terms inside the parentheses. When you do it right, you get our final, incredibly powerful profit function. P of x equals negative 2x squared plus 700x minus 5,000. This single equation now contains the entire financial story of our business.
All right, we did it. We have our map. That's the profit function. It can tell us the exact profit for any number of units we choose to produce. So the next logical step is to use this map to find the highest point on the entire terrain, the absolute peak of our potential profit. And this graph, this perfectly visualizes the whole concept. Because our profit function starts with a negative number, that negative 2 in front of the x squared, its graph is what we call a parabola that opens downward. And that shape tells the story of our business. When we start producing, our profits go up, and they keep going up until they hit one single highest point.
If we produce even 1 unit past that point, our profits start to fall. That peak, that highest point on the curve, has a special name. It's the vertex, and that's our bullseye. I want you to think about it like this. All of this math we've been doing, it all boils down to finding the coordinates of this one single point. The x-coordinate of that vertex is going to tell us exactly how many units to make, and the y-coordinate is going to tell us what our maximum possible profit will be. Our whole job is to find that point and steer the company right to it.
And believe it or not, this simple, elegant little formula is the key that unlocks the whole thing. For any quadratic function in that standard ax squared plus bx plus c format, this formula, x equals negative b over 2a, will give you the exact x-coordinate of the vertex. It's the tool that will tell us precisely how many units to make to reach the top of our profit mountain.
So let's walk through the calculation together. We look at our profit function, p of x equals negative 2x squared plus 700x minus 5,000. We can easily see that our a value is negative 2, and our b value is 700. So we plug those right into the formula. X equals the negative of 700 divided by 2 times negative 2. Well, that simplifies to negative 700 divided by negative 4. The two negatives cancel each other out, and we get our final result. X equals 175.
Okay, we have our number, 175. This is the moment where we stop being just a mathematician and we start being a manager. It is not enough to just find an answer on a piece of paper. We have to translate that number into a clear, actionable business decision.
So, what's the decision? The mathematical analysis is crystal clear. To maximize our company's profit, the factory's production target should be set at exactly 175 units. Not 174, not 176. Our model says that 175 is the number that perfectly balances our complex revenue and cost structures.
So we know the magic number of units to produce. That's fantastic, but it's only half the battle. As a manager, you also need to know what the payoff will be. You need it for budgeting, for forecasting, for setting the company's goals. So what is the actual dollar amount we should expect to see on the bottom line if we hit this target?
Well, finding that number is pretty straightforward. All we have to do is take our optimal quantity, 175, and plug it right back into the profit function that we built a few minutes ago. As you can see, we're calculating p of 175. This is going to give us the y-coordinate of the vertex, which is the actual dollar value of our maximum profit. And when you run those numbers through your calculator, this is what you get. $56,250. That's it. That is the peak of our profit mountain. According to our model, by producing exactly 175 units, the absolute maximum profit our business can generate is $56,250. This is our new target. Now, before we wrap this up, we have to talk about something that's just as important as getting the right answer, and that's avoiding the wrong ones. A mathematical model is just a tool, and like any tool, it's only as good as the person using it. Knowing these common pitfalls is absolutely key to making smart, real-world decisions.
I really want you to internalize these warnings. First, and I see this all the time, do not mistake maximizing revenue for maximizing profit. Chasing sales for the sake of sales can absolutely destroy your bottom line. Second, don't forget your fixed costs. They are real, they are relentless, and they have to be in your analysis. Third, please remember this is a model. It's a powerful simplification of reality, but it's not reality itself. And finally, and this is so important, don't just calculate this once and think you're done forever. Costs change, customer tastes change, and you have to be ready to reevaluate everything.
You know, this might be the single most important takeaway from our entire discussion today. Literally anyone can learn to plug numbers into a formula. The hard part, the part that makes someone a truly effective manager, is understanding the business logic behind numbers. It's about connecting the math back to what's actually happening on the factory floor and in the marketplace. That is what separates a calculator from a true leader.
So I'll leave you with this final thought to chew on. We found the perfect answer for today. But what happens to our entire model if tomorrow a key supplier of raw materials suddenly doubles their price? Think about it. Your cost function would change. That would change your profit function. The vertex of your parabola would shift. In the real world of business, the ground is always moving beneath your feet, and your success will ultimately depend on your ability to adapt your analysis and constantly find that new, sweet spot.